All right, guys, good day. We're going to start chapter 6 now, which is about systems of equations and inequalities. And in our first section here, we're going to talk about graphing systems of equations. So previously, we talked about graphing linear equations. So now we're going to pull on those skills to determine the number of solutions of a system of linear equations and also solve systems of linear equations by graphing. So some new vocab that's going to come up, and we'll talk about it as it comes up, are systems of equations, what it means to be consistent, independent, dependent, or inconsistent. So here's a situation that can arise. The cost to begin production on a band CD is $1,500. Each CD costs $4 to produce and will sell for $10. The band wants to know how many CDs they will have to sell to earn a profit. So if we graph the system, so the equation that represents the cost is 4 times x, so 4 times the number of CDs, it's $4 per CD, plus the initial $1,500, that's the blue graph. Now the profit they make is $10 per CD, so 10 times x. So we want to know how long will it take to earn a profit. So graphing a system can show when a company makes a profit. So here's the cost equation, and here's the profit equation. And notice the profit is less than the cost, so they still haven't made money until they get to about 250 CDs. You could see where they cross. And that's kind of like the break-even point, where the cost and the profit are about the same. And then after that, you could see that the profit graph is higher than the cost graph, so they're going to start actually making money. So the cost of producing the CD can be modeled by y equals 4x plus 1,500, where y represents the cost of production and x is the number of CDs produced. So the income from the CDs sold can be modeled by the equation y equals 10x, where y represents the income of selling the CDs and x is the number of CDs sold. If we graph these equations, we can see at which point the band begins making a profit. The point where the two graphs intersect is where the break-even point, the band breaks even, rather, and that's what I was talking about before. And this will happen when the band sells about 250 CDs. If they sell more than that, then they begin to make a profit. So the two equations, y equals 4x plus 1,500 and y equals 10x, form what's called a system of equations. The ordered pair that is the solution of both equations is the solution of the system. A system of two linear equations can have one solution if they just cross once. An infinite number of solutions, that's when both lines are the same, so they lie right on top of each other, so they intersect all the time. Or no solution, and which would be the case when the lines never intersect. Now think about it. What kind of lines would never intersect? Right, parallel lines. So if two lines are parallel, and it's a system of equations problem, there's going to be no solution. So if a system has at least one solution, it's said to be consistent. And remember, a system of equations can have one solution or an infinite number of solutions, because two lines will either intersect at one point, be right on top of each other, which means they're always on top, they intersect everywhere, which would be an infinite number of points, or they never intersect. So if it has at least one solution, they intersect or they lie on top of one another, then it's consistent. So the graphs intersect at one point or the same line. If a consistent system has one solution, it's said to be independent. Why is that? Well, that means that the two lines are not the same line. They're independent of one another. If it has an infinite number of solutions, it's said to be dependent. So you could have consistent and independent, which means there's exactly one solution and the lines just cross. If you're consistent and dependent, it means the two lines are the same lines when you graph them and they lie right on top of each other, and that means there's an unlimited number of solutions that satisfy both equations. If a system has no solution, it's said to be inconsistent and the graphs are parallel. So if it's inconsistent, you can't talk about it being independent or dependent, because independent and dependent are talking about what kind of solutions it has, and if it's inconsistent, there's no solution. So a graph can be consistent and independent, consistent and dependent, or plain old inconsistent. All right, so here's what it would look like. If you have exactly one solution, it's going to be consistent and independent, and they're just going to cross. If it has an infinite number of solutions, it's going to be consistent and dependent, and one line is right on top of the other. You can't see the red line because the blue line's like covering it up. And if you have no solutions, the system is said to be inconsistent, and the lines are parallel, never intersecting. All right, let's use the graph at the right to determine whether each system is consistent or inconsistent, and if it is independent or dependent. So graph A is y equals negative 2x plus 3. So it's the green one, and x minus 5, the blue one. So you could see that those two intersect only once. So the graph is consistent and independent. Consistent means that there's at least one solution, and independent means there's exactly one solution. Negative 2x minus 5 is the red line, and negative 2x plus 3 is the green line. You can see that these two lines have the same slope from the graph. They do not intersect, so they're parallel lines. So there's no solution, and therefore this system is inconsistent. All right, here's one for you to try. Go ahead and pause the video and then hit play when you're ready. Okay, we're back. So let's use the graph at the right to determine whether each system is consistent or inconsistent, if it is independent, and if it is independent or dependent. So 2x plus 3 is the blue line, and negative 2x minus 5 is the red line. So you could see they intersect at least once. They intersect exactly once, rather. So they would be consistent and independent. These ones, y equals x minus 5 is the purple line, and negative 2x minus 5 is the red line. And you could see that they intersect once. So again, they're consistent and independent. Let's just double check those again. 2x plus 3 is the blue line. 2x minus 5 is the red line. They intersect, consistent and independent. X minus 5 is the purple line. Negative 2x minus 5 is the red line. Intersect once right here, consistent and independent. All right, guys, that's it for this video. Please stay tuned for the next one, and we'll see you there.